A very good day to everyone. Today we'll be taking a look at a question on application of differentiation, mainly on the section on tangent and normal. What you have done in your secondary school on tangent and normal, the concept and theory can also be applied to H2 A-level math. The theory and concepts are not much difference. Probably the main difference is instead of giving you a simple Cartesian equation whereby you can differentiate directly, like y in terms of x, instead they will give you a Cartesian equation which is much more complicated, whereby you might need to utilize implicit differentiation. Or maybe sometimes they will give you a parametric equation instead. So this is the question we'll be looking at. So you are given the curve C which has a parametric equation of x equal to, let me just write it down. So x equal to 2t minus 1 over t squared and y equal to 2t plus 1 over t. And the point P on the curve has a parameter of t equal to 1. And first part of the question asks you to find the equation of tangent and normal to C at a point P. So for equation of tangent, I will want to use y minus y1 equal to m bracket x minus x1. I'll prefer to use this formula instead of the y equal to mx plus c because I just need to find the gradient and a point to define the equation of the tangent. Similarly, for equation of the normal, you'll just be y minus y1 equal to minus 1 over m bracket x minus x1, whereby the m is the gradient of the tangent. So for the gradient of the normal, you'll just be the negative reciprocal of it. Okay, so for the gradient, right, for a parametric equation, you will be define it to be dy dx over dy dt times dt over dx according to chain rule. So I will need to do a differentiation for x and y in terms of t separately first. So dx dt, when I do a differentiation, I'll just get 2 plus 2 over t cubed. And dy dt, you will just be equal to 2 minus 1 over t squared. So applying the formula for gradient of a parametric equation, I'll just get this over this. So you'll be 2 minus 1 over t squared over 2 plus 2 over t cubed. Alright, since the question wants us to find the equation of the tangent with real values, I don't think I will want to waste time to simplify this. Because after simplifying, you'll be subbing t equal to 1. Might as well, I can just sub it inside first. Right, so to save a bit of time, so when t equal to 1, I just sub inside t equal to 1 into here, I will get 2 minus 1 over 1 over 2 plus 2 over 1, which will just give me 1/4. Alright, similarly, I will need to find a point on the line. So I will just sub t equal to 1 into x and y separately. So when t equal to 1, x will just be 2 minus 1 over 1, which gives me 1. And for y, I'll get 2, 1 plus 1 over 1, which will give me 3. So I know my point P will just have the coordinates of 1, 3. Alright. And let's find out what is the equation of the tangent. So I'll just be subbing in the point and the gradient. So for equation of tangent, you'll just be y minus 3 equal to 1/4 x minus 1. Simplifying this, I'll just get y equal to 1/4 x plus 11 over 4. So for equation of normal, I'll just get y minus 3 equal to minus 4, reciprocal of the gradient of the tangent negative. So minus 4 x minus 1. Simplifying this, I'll get y equal to minus 4x plus 7. Okay, so pretty straightforward for the first part of the question. And for part 2 of the question, it asks for the tangent of P meets the y-axis at B, the normal at P meets the x-axis at A. If O is the origin, find the area of the quadrilateral of OAPB. I don't think I'll be able to do this question without a sketch. Right, I need a pictorial representation of what the question is asking for. Then I can visualize what is happening. Then I can find what the question wants. So maybe I can just do a quick sketch of this. So all this info I don't really need now. So all this I don't need. Okay, so using GC, right, I will be able to get the equation of the tangent and equation of normal on the diagram. So using GC, this will give me the equation of the tangent, y equal to 1/4 x plus 11 over 4. And for equation of the normal, it will probably look something like this. So I'll get y equal to minus 4x plus 7. Right, I know that this is point P, which is 1, 3. Okay, so it says that the tangent at P meets the y-axis at B. Tangent at P meets the y-axis at B. So I know that this point will be B. Okay, so I will be subbing x equal to 0 inside here to find the y coordinates, which will give me 0, 11 over 4 at this point. And the normal at P meets the x-axis at A. So I know that this point will just be A. And the coordinates, I will just let y to be 0 here. I'll get 7 over 4, 0. Okay, and this is the origin O. So the question wants us to find the quadrilateral of OAPB. So the area that I want to find will just be this portion here. Okay, I will think that I may want to split this area into two different parts. I can just drop down a vertical line here. Okay, at this point it will just be 1. I can see that this region is comprising of a trapezium and an area of a triangle. So I will just find area, it will just be this part plus this part. So let's find the area of this part. So for trapezium, the formula will just be half times sum of parallel sides times the width. So half times sum of parallel sides. Parallel sides will just be 11 over 4 plus 3. Here, the width will just be 1. And for the area of the triangle, half base times height, base will just be this portion here. So it's 7 over 4 minus 1 times the height, which will give me 3. Okay, so evaluating this result, you should be able to get a value of 4 and 4 units square. That will be the answer for my part 2.